Hey, good morning, everyone. Like you heard, I came down from Boston yesterday, so I missed the tutorials, but I had a nice train ride. Finished up some of the slides for this. So the talk I'm giving today is Sell Cron by Airflow, Modern Data Pipelines in Finance. So I myself am a site reliability engineer at Quantopian, so I'm not someone handling the finance side or even the data science side of things. I actually work on the infrastructure and the systems, but I've done that at other data roles before. So I did that at the Harvard Center for Brain Science. I've done some other stuff as well, sort of jumped all over the map. I like variety, so it's a really good job for me because it means I get to support what everyone else in the company is doing and learn a little bit about a bunch of different technologies. But personally, I actually came from a background of academia and public policy, so I did work that was pretty similar to like modern data science work back then, and then shifted into being more of a back-end person. So again, as a first disclaimer, I'm an SRE professional. I can tell you all about Unix or networks. I can't tell you about financial regulation, so I'll give you that disclaimer. Opinions expressed in this presentation are my own and not Quantopian's, even though I'm talking about what Quantopian does. And this presentation is not investment advice. Why do I say it's not investment advice? Well, there's actually restrictions on who can give you investment advice, and as it turns out, the SEC takes this extremely seriously, unlike some people. All right, now just as a show of hands, how many folks have heard of Quantopian before? Oh yeah, cool. It's always glad to see some fans in the audience. Just to kind of recap what we do, because I did see some people who didn't raise a hand. We provide a lot of education about how to use either Python for finance, or if you already know Python, how to actually learn the financial concepts to build models against essentially the stock market. We want anyone in the world to be able to pursue quantitative finance, to do it in a browser, to not have to do Python dependency management to get up and running. So it's all Jupyter-based, but it's not just technology. It's also the combination of the education that we do and the data that we provide on the platform. So it's really easy to get basic financial data, but if you want to have a high-performing algorithm on the stock market, it needs to be cleaned data, it needs to be more up-to-date, reliable. You need types of data that aren't available to consumers for free. So, back in the days, people would do your Yahoo finance data and base an algorithm off of that. If you want to get better results than that, you really do need cleaned data, and that's part of the value proposition that Quantopian is providing. Okay, so why would you actually write an algorithm with Quantopian other than that it's fun for some people? Well, we also provide allocation. So if your algorithm performs well on Quantopian, we'll actually sign something with you to allow us to invest money in it and give you a share of that money. So effectively, if you don't have the capital, but you do have the skills, Quantopian is a really great value proposition for you. Now, Quantopian has recently partnered with FactSet, which is a new data provider that we've added and we have a larger partnership with. They're one of the largest financial data providers in the world, so it's really hugely expanding the scope of the types of data that we have on the platform. For instance, we've started adding international markets. Previously, we just had US equities. Now we have several markets with many more coming soon. We also recently added the ability to bring your own data to the Quantopian platform. It's self-serve data. What this means is you can not only just write an algorithm on Quantopian, but you can every night import the latest data. Perhaps you have some model that you're training yourself off of Quantopian. You have some interesting web scraping that you're doing. Things that you can't do within the Quantopian algorithm API, you can still upload and integrate with your algorithms. So why am I talking about this stuff? Because as an SRE, it's my job to support all that. If you have a nightly data pipeline, it needs to actually run, and if there's a problem with it, someone needs to get woken up and to fix it. At Quantopian, that's people on the SRE team. So what is an SRE? It's a site reliability engineer. And that means that I'm working on any kind of problem that would affect the reliability of our ability to develop, deploy, or operate services. So yes, that means actually running the servers, but it also means logging, monitoring, build systems, consulting on initial architecture, like deciding which database we're going to use or where we're going to store files. So it's a mix of traditional operations work and something closer to data engineering, like actually understanding the domain that you're working in. The way that we do teams at Quantopian is that every SRE gets attached to one of our development teams. The team that I'm attached to is the Black team, which does a lot of our data infrastructure, particularly for the investment side of the house. So Quantopian is actually placing trades. We have an execution engine, so we need to have all of that infrastructure set up reliably. And it's a little different from the nightly work that we do to provide free data on the platform, because it's actually interfacing with a lot of external vendors and placing trades and sending it to them. Also, because of that, because it's actually trying to turn a profit, we have a data science element to this. And we take a lot of the data science stuff done by other teams and try to productize it so we do feel comfortable backing it with money. So for the rest of the presentation, when I talk about our data pipelines, when I say community data, I'm talking about what you see if you make a Quantopian account and log in. So the data that you can use in your algorithms that you can start building models based off of. And this isn't just like we download some stuff and we expose it to you. We actually do our own processing to make it performant, aware of look-ahead bias. We have our own file formats that we use for handling this. We also produce our own portfolio risk model, something traditionally only available to large institutions, but we've made it available to the whole community. But we're a startup. We're like any other modern startup. A lot of the data work we do is just everywhere in the company. Everywhere in the company needs to do data work to be an effective startup. So that means that we have just analytics data, who's using what features, where are people coming from, where are they in the acquisition process. And we also do analytics on our own performance. So those trades that we place, we need to understand, did they go as expected? What was the profit and loss there? Is there something we can do to manage risk better? We also have a team dedicated to just onboarding like new experimental ideas, data science projects, new data sets, new partner integrations. So there's a lot of exploratory work that happens around data. So we're really data-driven company, but we're also a company that has data as part of our core domain. So we get it on kind of both sides there. Now, as you know, more data, more problems. And it was actually around this time last year that I got tasked with improving our ETL processes. So we had some initial set of criteria, just sort of describing the problem, and I did some initial research into what our problems really were and how we might go about fixing them. One of the problems that we faced is that we had a really high need for reliability, because if you have trading infrastructure, you're trading an investor's money, you have a lot of legal requirements on how you place those trades. You have a lot of requirements on reporting and compliance. So it's not just like, you place the trades and that's it. You have to do work before you can place the trades. You have to reliably execute the trade, and then you have to do follow-up work to do the accounting for that and to attribute profit to that. We did actually operate at really high reliability before this project, but it was coming at a very high human cost. We were frequently getting paged, having to do things manually. It was not a sustainable way to do development, not in the sense that it was, it wasn't an insurmountable problem for the team, but it was affecting the speed at which we could develop new features. And that's actually a huge problem when you're interfacing with a market. It's all about agility, because alpha, the profit you find in a market, tends to decline. So even as it's important for a startup to move fast, a startup that's actually placing trades, it's even more crucial that you have the ability to iterate quickly. And our high reliability was at a point where it was dragging down our velocity, when really the two don't have to move in opposite directions like that. It's possible to be very fast and very reliable. Of course, you all know this problem, so I don't have to explain it as much. Even when you have a large financial data vendor, even if it's not just data that you scraped yourself, there are just issues in it. You have to be able to account for that. We do have a lot of automated data checks, but sometimes they weren't getting run except by manual effort, or they weren't picking up on some of the real world issues that we had. So we needed a system that could cope with this. One of the main pain points of this system is that it was based on crontabs. Now, if you're not like a sysadmin type, if you haven't heard of cron before, it's just a really simple scheduling tool. It runs things on a very regular schedule, so hourly or nightly or every third day in the month of December or something like that. And it's great for getting things running when you have like one system that you're maintaining yourself. It's a very easy tool to use. But it's very limited when you start talking about having dozens or hundreds of these cron tabs. It's very limited when you start talking about alternative calendars and schedules. It's very limited when it comes to reporting. So it's a good tool to get up and running fast, but it's not a maintainable and sustainable tool when you have a lot of teams starting these scheduled jobs and needing to understand the impact of those jobs failing. Now, because of some of those problems with cron tabs, because cron provides so little logic in its scheduling system, we actually had to add a lot of additional scheduling logic inside the scripts that we were calling. And that meant we had logic baked in dozens of different places with slight differences. So it became very hard to understand our data ecosystem, why things were making scheduling decisions, why they thought they should run with this flag on this day and a different flag on another day. So all of this combines together to create a bottleneck, because in any kind of finance company, there's tighter controls over who has access to servers and who can deploy things. So SREs became the bottleneck for managing all this complexity, and it really limited our ability to iterate quickly. So we wanted to fix our data pipelines, but before we could do that, we needed to talk about the business goals that we were trying to achieve, and that would help us pick out a system. So of course, reliability was one of those major goals. We wanted to just not have these kinds of problems. We don't want jobs to fail at all. So that's the best way to not get woken up, if you just don't get paged because the system is working. But we know that it's never going to be perfectly reliable. We base this off of other people's data, and there are always going to be issues around having external vendors. Even if we do everything right, one of our vendors could still have an issue. So we need to be able to diagnose that quickly. There's this concept called observability. So if you're familiar with the issues that people in the ML space have been having with like understanding why their models make that decision, well, you actually run into a lot of the same problems in a very complex distributed live system. It's very hard to trace what was producing data, what data was available at what time, why your systems made certain decisions. So it's a lot of the same goals of being able to trace that through the entire system and understand why your application made a decision. And as I've mentioned, velocity was a core goal in this. We wanted not just to take our existing system and make it better, but we wanted a fundamentally new system that made it easier to push changes very quickly. So it didn't need to be a week-long effort to add one of these new jobs, something where you could just push new code, and if the test passed, it would be running. So that might sound familiar, some of these problems. If you're working in a data science department, you've probably encountered some of them. The answer is that most companies are facing this type of challenge, the same way that most companies are also facing challenges adopting the ideas of DevOps. Once every company starts needing to manage data and run in the cloud, they all start having very similar looking problems. That being said, every company does have some unique aspects, and one for us at Quantopian is democratization. What I mean by that is we want decision-making to be shared within the company. We want people to understand what everyone's working on. So we're very transparent, both about to the external community. We want everyone able to be involved in quantitative finance. But internally, we want all the teams to understand each other. We're not like traditional kind of finance where you think of like very siloed teams that are secretive about how they're making profit. We don't do that in-house. So we wanted something where anyone could just send in a pull request, much more similar to open source development, even though it's for internal closed projects. Two other notes here. I just want to emphasize we're not talking about solving big data in the sense of like Hadoop clusters. We're not running off of huge amounts of log-based data. We already had very well-performing file formats tailored towards finance data. We're not talking about streaming financial data. So this is not high-frequency trading. That's not the space that we're in. So we're talking about batch, nightly ETL jobs, where the jobs are of high complexity, but they are a very constrained data size and schedule. So it's more about managing the organizational complexity of these processes. Well, we're all cloud-based. We wanted to make sure that we could run whatever tool we were running within our own account and have ownership over it. We also wanted to make sure it was not an ETL-specific tool or a data pipeline tool or a data warehousing tool. The reason being that on the SRE team, we have to take what are called orchestration actions in response to data. So by orchestration, I mean starting up a new cluster, deploying code to existing servers, things that are not strictly data tasks, but that relate to new data that's being published. So we always want to make sure the freshest data is on the platform, and sometimes you need to take steps that aren't just as simple as inserting records into a database or pushing a file to S3. So some systems are very locked into that mindset. We also knew that we wanted this to be a system that was a directed acyclic graph. It's just the most natural representation for a sequence of ordered tasks like this. So cron doesn't provide that at all. All of the times were just, this runs at 9:05, we think it's done in 10 minutes, the next one runs at 9:15, except we built in a buffer, so it actually runs at 9:20. Yeah, once you have 100 of those, that just doesn't work at all. So that's good for your first project, but it was time for us to have something that actually tracked dependency relationships. That's what that looks like in Airflow, by the way, which is the tool we did end up selecting. We also needed something that had real scheduling logic. This is what it just looks like for the US exchanges. And you can see they have different holidays. Some of the holidays are partial days, not full holidays. They close and then reopen. So there's actually a lot of scheduling logic complexity. By the way, every market is on a different schedule. Sometimes there's more than one market per country. Those countries are in different time zones. Some countries observe daylight savings at different times. So this is like a huge scheduling problem. There's so much complexity once you're starting to work across 10 countries, 20 countries, even more. We needed a tool that could actually express this in a reasonable way. Python is actually pretty good at that. There's a lot of capabilities to do this sort of thing in Python. That's not true of bash scripting. So actually, I also have done work at MRI lab, in my case, the Harvard Center for Brain Science. This is what a brain MRI processing pipeline looks like. So these are all the steps in the pipeline. You can see they fork and join. And one of the interesting things about that is that some of these tasks could take like 24 hours to run because you're working with like 3-dimensional float data at very high resolution where you're talking about like millimeter voxels and things like that. So what that means is it's very expensive to recompute things. So there's a lot of use of more functional data systems where you save every intermediate step in an architecture like this. And that's actually this kind of process that we wanted to adopt with our system. We wanted a more functional data pipeline system where rather than one big instance that's really powerful and it does a lot of on-disk processing and moves files from one location to another, we wanted checkpointing built in at every step of the system. So it would upload the artifacts to, in our case, S3. And then if the step after that failed, we could rerun just from that step. It's a much more functional and immutable way of thinking about data. So taking all these put together, for us the choice was pretty obvious to adopt Apache Airflow. This project came out of Airbnb, that's why it's called Airflow. And it's a really out-of-the-box tool for doing a lot of this work. Airflow is currently incubating, so it's going to be part of the overall Apache project soon. And it's on version 1.10, with version 2.0 coming fairly soon, probably next year. You get a lot out of the box with Airflow. It's not a command line tool. It's actually got features for a web interface. So you can see all of the executions of your tasks, whether they succeeded or failed, the schedule that they're happening on, the dependency relationships between them. And it's really got some great observability features and some great operational features. It actually understands the difference between the person writing the model, the person viewing the logs from the model, and the person who's managing the cluster administration. And that's really great from the perspective of an SRE. I don't actually know what a lot of the jobs running on the Airflow cluster are. I don't have deep knowledge of that code, but I do have a lot of knowledge of what our overall nightly process should look like because it's my job to keep that running. So it's a tool that's good whether you're focused on one specific task that it's your responsibility to run, or whether you're responsible for the overall operations of the cluster. It also tracks a lot of execution data. So you get like overnight data on how long tasks are taking. You can even do alerting based on that. So if like a task you usually expect to take 2 hours and it takes 4, you can actually have it send you an email, or in our case, a PagerDuty notification, so you find out about that and can fix it. Another really nice feature for Airflow relative to a lot of the competition, if you've used things like Pachyderm or Luigi, those seem like fine tools for a single ML engineer, but that's not the use case that we have. We need to put things in production. They need to run at large scale. They may need to keep running when that team has moved on to some other project. So my team is all about productionizing things. And Airflow is already a heavily productionized distributed service. It has different classes of workers. It has a metadata database. It has its own task queue. So it's not something where you have to figure out how you're going to take an Airflow client and lift it up into the cloud. It can be cloud native from day one, which is a really appealing feature in this kind of data processing system. One final note, it's a Python project. I love Python. I wouldn't be here if I weren't a Python fan. I actually have a Python tattoo there. Import this right here. Okay, so you've heard all about why I like Airflow. Let me show you some code from it. This is what we call an operator. So if you think back to a DAG, it's a graph, and what do we call the little dots in graphs are nodes. So an operator is one node, so it's like one task that you're performing in the graph. This particular one is aware of trading calendar holidays. So it knows what the holidays are for a particular market's trading calendar, and it knows not to perform downstream actions on that day. So it's very simple. It's just like a Python function that you just write in a more constrained framework style of code. And once you have these operators written, and by the way, Airflow comes with dozens of these out of the box, you can actually chain them together using the bit shift operator as a shorthand. And this is a super serious business problem that we have. We all subscribe to a meal ordering service individually, and we need to put in our orders by 10 a.m., and we often were missing it because we would get to work and forget about it. But we can't just order it every day because we're closed on stock market holidays, and we get catered lunches on Wednesdays. So we actually have a complex set of business rules for when to order lunch. And that's what that looks like when you put that in the UI. It's aware of which days are company meetings or not. It's aware of which days are holidays and weekends. So it only sends an @here Slack notification when there are like actually people in the office. So that's what it looks like. It's like we have our own little chat bot, but it's not just a cron schedule. It's a schedule that's aware of our domain. So when do we put stuff in Airflow? For us, there are a few considerations. One is if the cron job has to be resilient or distributed, that's a plus for putting it in Airflow. Another is that if it has any upstream data dependencies or any downstream data dependencies, so it either consumes or produces a data artifact, that's a definite plus to putting it in Airflow. And the third item there is that if we think anyone in the company might want to extend this to add their own logic, maybe it's not an official step, but like they just want to know when this data load finishes every night, or they want to restart their development instance based on this data availability, that's also a candidate for being in Airflow. So if it's got even one of those things, it's a pretty good fit for Airflow. If it's two or more of those criteria, it's a great fit for Airflow. So here's what our nightly data load process looked like when we started putting it in Airflow. We would decide whether we traded yesterday. If we did, we had some other non-Airflow services that would be producing data, and we would wait for them to complete. And if they did complete, we would start queuing some tasks downstream. If all those tasks queued successfully, we would replace some of our services as well as run the nightly Quantopian contest where we simulate your performance on the results of the data from that day. And that's what that looks like in Slack. We get some really cool notifications about when things are running. We have links back to the UI. So if I get paged at 2 a.m. or 3 a.m., it's easy to jump in and understand what ran as intended and what didn't run. Because it's not always as simple as just, oh, something failed, I have to restart it. Sometimes it's like, oh, this failed, and this had an undeclared dependency, so I need to actually go figure out everything that ran using the corrupt version of data and roll everything back, and then fix it, and then start again, right? Those are the kinds of data problems you have when you're in a production environment. And having it all in a linear list like this, but still with a graph representation, makes it really easy to debug. So this is really successful, actually. So that's V2. And you can see it just kind of keeps growing as we add more stuff to it. With that FactSet data partnership, it actually now looks like this. So we added Asia Pacific and EU as data ingestion steps there. And as we start linking more of these types of data to each other, as we start running on more calendars, this DAG will just grow and grow. I have one other example I wanted to talk about from an operational side. It's one of our existing services called FileMover. FileMover is just like a data transfer service. It knows how to log in on FTP and SFTP, and well, that's basically all anyone in finance uses. FileMover breaks all the time. And I don't mean that because like FileMover is bad. The reason it breaks is because FTP servers go down. The files we expect aren't there. They didn't get published that day. They were operating on a different calendar than we were. The file got published late, so it did eventually show up. Basically, we have this brittle crontab-based system for data transfers, and it was missing a lot. We were getting paged almost every day on average. And because it had crontabs, we couldn't run this service at certain times of day to ship it because the service was running on a single instance. So it wasn't a very reliable system, and that's why it caused so many pages. So we hired an SRE intern over the summer, Danny, who actually is going to be working with us on an ongoing basis. And because we tackled as this summer project switching this existing service to Airflow, she was actually able to merge like 70 PRs over the course of one summer as an intern coming into this without prior knowledge of either finance or of like SRE. So this incredible productivity tool, being able to port this existing system to Airflow basically over the course of a summer. And to do it in an evolutionary way where we could move jobs over one at a time as we got more confidence with the Airflow system. So that's what that looks like now. It's the same thing that was here. Everything runs at about the same time, but instead of a flat time-based representation, we now have a graph-based representation. We can understand where the dependencies actually are. So that's what that looks like to have that gradual rollout, where you have a task that doesn't exist, so it's that white icon. Also, there's lots of holidays. That's whenever you see like an irregular pink line, those are tasks getting skipped. So like 3 days in a row is like Saturday, Sunday, and a Monday holiday. Okay, so the last example that I want to talk about is something that's really new for us. It's what I have been working on over the past 3 months or so. We're calling it the Quantopian alpha model. It's a way to dramatically increase the number of algorithms that we're including in our community allocations. Basically, every night we're running this data science process on the result of community algorithms. I can't talk about much of the details about how we're doing it, but it's all based on Airflow and Kubernetes. So essentially, each one of these steps is a containerized Python process that we're using Airflow to schedule and link all the dependencies between. And then at the end of each of those steps, we upload those artifacts. And that's actually been immensely successful for us because we built this entire project from day one running on Airflow. This wasn't like we had some existing project and forklifted it into Airflow like we were talking about with FileMover. We were able to use Airflow's strengths from the beginning. And one of the real strengths here is that the team who's implementing this data science work has a real production cluster that runs exactly the same as our nightly data loads for running something that's still in development. Every time they make some change, they can push out a new container, they can log into the web interface and rerun tasks, they can understand and get their own failure notifications. So this doesn't go to SRE if it fails, it goes to the team that is responsible for pushing out all this code. It's like we built this platform for them and it's up to them to make the most of that platform. So I really love the combination of Airflow and Kubernetes. If you haven't heard of Kubernetes, by the way, it's a cluster scheduling tool that came out of Google. It's sort of like Docker, but taking those containers and running them in the cloud at a very large scale. So you can send as many containers as you want to, and it will just figure out what machines to start or where to put those containers. You, as a developer, don't have to think about it at all. So we're a year into adopting Kubernetes at Quantopian, and we're also about a year into adopting Airflow. And the two really work well together because Airflow has some problems around dependency management. It's a Python process, and a lot of the DAG code that you write and a lot of the task code is also running in Python. So what does that mean? If core Airflow has a different Python dependency need than your operator does, it actually sucks to manage. And Kubernetes, on the other hand, it uses containers, so you just package up all your code into a container and ship it, no dependency problems, but it doesn't have any concept of dependent scheduling. It has a highly available, resilient cron job system, but you can't have cron jobs trigger other cron jobs in any useful way. So what do you get when you put them together? You have the ability to write Python code for your data science project, bake it into a container, and schedule it on a highly resilient backend using more Python code. So all you have to do as a consumer of this is write a lot of Python, and y'all are pretty good at that, I hear. So Quantopian really loves Airflow. It's seen a lot of adoption for something that was basically like a one-person project to get this up and running. We have a lot of our systems that are reliant on it at this point. If you're in a position of you think that the code you're writing is going to be run in the real world on a production system night over night, I think Airflow is a really strong candidate for that if it meets the criteria that I discussed earlier. So I love Airflow, but you don't have to trust me because so do my coworkers. Some screenshots of what they've had to say about it in Slack. So this happens a lot, right? Someone will move something into Airflow. Someone else won't even know that that was in Airflow until something breaks and it's suddenly much easier to fix it. So I feel a little obligated. We are hiring for the SRE team that I'm on as well as for software engineers. If you're interested, you can come talk to me. How am I doing on time for this one? 8 minutes, great. So I want to talk a little bit about future development as well, because Airflow gets you a lot out of the box. It does have some warts to it, some things that it's missing. Actually, Jeremiah, who is one of the speakers today, is going to be giving a talk on Prefect, which is the tool that he's been working on based on his very lengthy experience with Airflow that addresses some of these problems. But there's also efforts to address some of these problems in Airflow itself. One that I'm passionate about as someone who gets woken up when Airflow fails is I want enhanced SLAs, service level agreements. Airflow has a feature for this where it can warn you if a task takes too long or doesn't start at the expected time. I actually have a pretty lengthy PR to revamp this and in general improve the operational features for people like me who administrate Airflow clusters. One thing that I think is really relevant to developers is that there's a lot of opportunity to have unit tests for Airflow DAGs, directed acyclic graphs. Because in a normal test suite, you're testing every step in isolation. You want to make sure that things publish to the right place, that they load their config file properly. You should totally write unit tests. It's great. But as someone who runs this kind of thing in the real world, unit tests don't solve the hardest problems in data science. Figuring out where the data is stored, making sure that a schema change in one producer doesn't affect consumers downstream. It's very hard to unit test that. But you already have a structured representation of your graph. You know what task that's trying to execute. I think there's a lot of potential here to base this on historical data to be able to run tests that simulate failure conditions. Like, what would happen if this task failed and had to retry? Would we still meet our nightly goal deadlines? What happens if we have a 95th percentile slowdown? What if it's a 99th percentile slowdown? How does that impact everything else downstream in the graph? You can simulate that using Airflow a lot more easily than you can a list of cron jobs. So I think that there's real potential there for adopting this as a form of testing. Data lineage, as I've mentioned several times, is a huge problem. And actually, Airflow already has some integration with this. It's not as well documented. It was sort of just added, but I expect to see more people adopting it. It uses Apache Atlas as the backend. And this is going to become a huge deal for a lot of companies. Once you start thinking about GDPR compliance, being able to understand what data needs to even be revoked, how do you know what your transformations are producing and where that actually is going? That's going to be a huge need for a lot of companies, and to have that baked into your execution system is going to be very powerful. So I think that's a very compelling feature for Airflow. All right, now it's time to talk about one of my passions, graph theory. So you already have all this cool stuff in a graph. Graphs are great. Airflow is not doing anything with graphs other than scheduling. So what other stuff could you do on graphs? Well, you could run algorithms on those graphs. Like I just mentioned, you could do some sensitivity analysis. What happens if one of the nodes is disturbed? What happens to the downstreams of that graph? One thing that I'm really interested in is, can you take an Airflow DAG, can you take a Git branch of that DAG and understand the diff between them using graph theory? And I actually found some pretty promising algorithms for this, like being able to understand what branch of the DAG is considered new, and being able to spin up a testing environment that just tests that code, or that understands that in this PR, you're adding this new set of dependencies to these features. Again, this is something that Airflow doesn't directly address right now, but all the building blocks are there. So I think there's like really healthy room for development. So I want to thank you all for coming to this. And I think we have a little bit of time for questions, like a minute or two. Oh, thank you.
I guess my question would be, how do all your DAGs live in one Python module? Because when we've been working, making DAGs, kind of the DAG folder, at least like the basic level, everything gets deployed in the DAG folder, but we organize it as if it were a Python module. And like, do all your DAGs live in one repository? Do you assign them to, like, say, the project that is going to get run on your Kubernetes operators or whatever you were talking about there?
Yeah. So we have two systems for doing this. One is the legacy one, where we essentially just have like a folder that has all of our DAGs, so like a flat list. And that's fine. We deploy off of that repository. It can embed other Python like helper functions if you need to, that it's sort of preferred to put that into a more composable library. And that's like a fine approach. It sounds pretty close to what you're doing. What I've really liked is the approach that we've added for that Quantopian alpha model project, where we have a new repository that's all based around like Docker file builds. And it has a concept of, here's the subfolder for one particular project, the related DAGs for that project, and any of the container builds that are specific to that project. I do think it's a good pattern to keep all of this in a single repository to the extent possible, rather than doing something like importing DAG code from the service that you're managing with the DAG code. I think centralizing it is good. It helps with more complex pull requests, to be able to pull request against multiple DAGs in one go, because even if you split things into DAGs, they often have relationships between each other because they use common resources. But I think that the way you're doing it seems fine. The one caveat I'd add, we haven't found any benefit to putting it as a Python like installable library as opposed to just copying the files. I think that that has actually added some challenges for us, is making the DAG itself be an installable Python package.
Got you. Thank you.
Yeah. Yeah.
Can you talk a little more about the compare and contrast between Airflow and things like Pachyderm? Because, you know, one of the more kind of more advanced use cases for Airflow that you talked about, that especially those that deal with data, that makes it look more like Pachyderm.
Yeah, so I did evaluate Pachyderm. I didn't get much hands-on experience with it, but it was one of the like 15 or so tools that I compared for ETL services. And it looked like a pretty cool tool for if you're like an individual engineer working on a data science project, but it's very heavily based on a file system concept of moving data around. It's very oriented towards a machine learning use case. Almost everything that we're showing you there is not machine learning, or it's a constrained machine learning project that doesn't need to be run on that kind of like pipeline. So I'd say it's actually fine to have separate tools there. It might make sense to use something like Pachyderm when you're developing a project, but the options for taking that and running it in the cloud on a nightly basis and having a different team run it, they were not as compelling. Some of the paid features look like they might approach that. But we didn't want this to be something where you are running these tasks on someone else's servers. We wanted it entirely self-hosted. And overall, Airflow is very oriented around that use case. So we wanted to choose something that was a good fit rather than taking something that was good for the initial development experience and focusing on that. Because most of the time that a pipeline runs, it's not under development. Usually they do eventually get to a steady state. And it's managing the complexity of maintaining that number of pipelines with small incremental changes that's actually very challenging. Because people will tend to forget what pipelines even exist or what data dependencies exist. So it's sort of a very different use case in that regard. Also, I have heard some very bad stories about the more file system-backed tools like this. One example with Luigi, I saw a presentation about that where they described one data issue they'd had where they waited for a task to run based on the existence of some folder that gets produced by the previous task. And that sounds good, except that the previous task produced the folder before it produced any files in the folder. And because it's such a file-oriented notion of task completion in Luigi, it immediately ran the next step with a blank folder and like ended up corrupting production data. That's the kind of thing that's very scary to me as an operator. I don't want anything that assumes that the files exist on the file system, that that instance has been running previously, that it has packages installed. I want everything like that expressed in containers and expressed in understandable data definitions. Yeah. Oh, no time. Okay, sorry. I will be out there if you want to ask me questions later, like lunchtime or so. Thank you.